Okay, so the problem's asking, it says we have two charges at a certain point, and we have a point where we want it to be the E to be equal to 0, and we're wondering where a third charge could be to make that happen, essentially. So let's start drawing it out so it makes a little bit more sense. So since x is equal to 0 at every single point, we can just rock a zy plane. Don't even need an x-axis. Don't even need to worry about x at all. And then let's put these 2 points. So 0, 0, 1 will be right there, and 0, 0, negative 1 will be right there. Now we're going to have a point where e is equal to 0 at 0, 1, so that would be right here as for our graph that we made. And we'll call that point P before I change colors. And let me go back to red real quick because I can show you what's happening with these two charges before we move on. So these two Q1 charges are going to have, this one's going to have a force or an electric field vector like that, and this one's going to have an electric field vector like that. And what's going to happen is the z components are going to cancel, but the y component is actually going to double. And what that breeds is a vector that looks something like this. It's going right along the y-axis. Boom. So we're going to have a third point either up here or down here that's going to be an equal and opposite vector so that this blue point P is going to have E equal to 0. That's what we want. So we need to find out where on the y-axis. So we know it's going to be on the y-axis because if it was over here, you know, there'd be some z component that's not going to make it 0. So it has to be on the y-axis somewhere. We're just going to try and find out where. So let's start by mapping out the electric fields and start looking at that. So E total is going to be equal to 2 electric fields. We'll say this one is E1. E1 is going to be in red to show that it's from these two charges right here. And then it's going to be added. Oh wait, excuse me. It's going to be subtracted to E2. And those two will result in 0. This ET right here has to result in 0. So let's set that to 0 right now. Boom. 0. Okay, so what does that mean? E1 is going to be equal to E2. Simple as that. E1 is equal to E2. So let's start with E1. First, let's get some information. First, we need to know R because we're about to do Coulomb's law, right? So let me make a little triangle to map out what we're doing. So that's negative 1 to 0. I'm basically just representing a bigger triangle over here. That's a negative 1 to 0, so that's going to be a distance of 1. That's a 0 to 1, so that's going to be a 1. This radius, or this distance must be a root 2 by Pythagorean theorem. And we also know that if we just wanted the vertical component of a 1-to-1 triangle, it's going to be sine of 45, right? Simple enough. So, you know, because it'd be 1 over square root of 2 either way. Sine of 45, 1 over square root of 2. Okay, so let's write it out. So we have two charges, so it's going to be 2q1 over, let me see, I didn't like how that q1 came out. 2q1 over 4 pi epsilon naught r, but r is going to be square root of 2, so I'll write that out now, square root of 2 squared. And then don't forget our sine of 45 because we're only dealing with the y component. Because if we didn't have that, it'd be representing the direction over here, and that's not what we want. We want the direction of vertical to it. So sine of 45. Okay, so that's all for the left side of the equation. Now this one, we have to do a little trickery. I'll do this one in green just because that's what it's representing anyway. I could have did this one in red, but it's okay. So we have a choice. We can either use this bottom charge here because we know it's going to have a bottom charge and a top charge. So we can either do the bottom one or the top one. So let's do the top because what we can do is we can make this an absolute value of Q2. And now we know it's coming from the top side. And here's what that does for us. 4 pi epsilon, that's going to stay the same. But R is going to be y minus 1 now. And why is that? Let me explain that. Because we know it's going to have some distance y, but now it's going to go 1 less than that distance. Why is it 1 less? Because this is up 1. So all we know is this is just going to be a y minus 1 distance. Really, really simple way to get your r. So now we have that figured out. So now we know 4 pi epsilon naught is going to cancel on this side and that side. So boom, boom. This 2, this square root of 2 squared is going to be a 2, which is also going to cancel with that. And then we're left with, this will turn into a 1 over square root of 2. So we're left with q1 over square root of 2 equal to the absolute value of q2 over y minus 1 squared. Give us some space, bring it over here a little bit. Okay, so we want this y value. That's what we're looking for, because we're looking for where on the y-axis these two charges are going to end up. So I'll bring this one over. Y minus 1 squared. I'll bring the q1 over and the q2 up, so it's going to be q2 over q1 times square root of 2. Now, to get rid of this square right here, we just have to square root everything. y minus 1. And we can't forget that it's going to be a plus or minus now because we're square rooting, right? This will be absolute value q2 over q1. And this will be 2 to the 1/4 now, because you're square rooting a square root, so that's going to give you a 1/4. So once you add this 1, that's your result. Y is equal to 1, because we add over the 1, plus or minus square root of q2 over q1 times 2. Oh, that's the absolute value sign. Times 2 to the 1/4. And there you go. The end.